Okay, so the first thing, and you need to get your calendars out because I want you to mark your calendars. Your last day of class is Monday, December 3rd. Wait a minute, our class don't meet on Monday. Then your last day of class is 11/29. Why do I have to tell y'all this?
It's this month.
Because people will show up Tuesday morning in this classroom. Even though the last day of class is Monday. One of these people that don't come to class, they're going to come to the classroom at Anderson. They're going to come to the classroom in Pendleton. Well, there's only one person, Oconee, so she's here. But somebody will show up at each of these campuses thinking that the last day is Tuesday, the 4th. They always do. So that means that the last day, you are responsible for any material covered up until the last day. I usually put that on the last test. Now we're going to get these vectors in. That's going to be your 4th test, and we'll probably have another test, which will be a 5th test. That 5th test, I'll put on there, last test. So that way you can't say, oh, I didn't know we were supposed to do that. No, it says last test. That means you're supposed to do it. Okay? It'll be due the last day of final exams, which will be on the 7th. So you have a whole week to take it. Okay? Now, the exams. This is the second bonus question that you've been reading throughout the semester. Is everybody writing this down?
Yep.
Okay. I don't want to see anybody doing anything but writing. Okay? Because I don't want to hear these questions again. The exam is 12/4 through 12/7. Now, when you go to your handy-dandy page, I'm going to show everybody this because some of y'all don't know it. Because it's not told very well to students, or however it's not conveyed. Let me go to the TCTC. Thought I had it down here, but I guess I don't. When you go to your TCTC page, and you put in your credentials, look down here. There's two things I want you to see. Academic calendar, that tells you the last day of classes, the final exams. Let's go ahead and look at that in case we need it. Fall 2018. And look at there. I'll even blow it up for some of y'all. Now, why am I putting it down here? Because we're in November, that's why. Look at there. Gives us all kinds of information. Isn't that very, very valuable information? That way y'all don't ask that stupid question. When are we not here? When are we on Thanksgiving holidays? I have no earthly idea. Exams, that's for session C. You read session A. Last day of class, December 3rd. Final exams, December 4th through the 10th. Well, what if I need to know my exam schedule? Then you hit exam schedule.
Oh, wow.
And if you go to the Pendleton campus, you go to the Pendleton campus. If you go to the Anderson campus, you go to the Anderson campus. Now, I don't know how they've got this listed. I'm going to look at the Anderson campus. I would assume they did the polycoms. I don't see polycoms on here anywhere, so I'm going to go with the Anderson campus. Anderson campus, what time we meet? 11?
11:15. Thursday.
11:10. 11:10.
Tuesday and Thursday.
Okay, Thursday, December 6th. That's easy for me to remember. That's my birthday. Everybody bring me money. Okay? December 6th. That's my birthday. Bring me money. That's a joke, okay? Some dumbass will bring me $1 or something. Or $2 bill. Yeah, that's it. $2 bill. All right. 10/10 to 12/10. Everybody got that? So if you go to the Pendleton campus, let's go to the Pendleton campus. There, they've got these. Okay, let's look at 11:10. Tuesday and Thursday. I'm looking for it. 11:10. It says December 4th. So I guess we will just meet. I don't know how we're going to work that out. Oh, hell, I won't be able to give an in-class test. Oh, well. See, that's why I don't know how we're going to work that out. We're going to have to figure it out because I'm looking. I don't see December 4th.
That's the last day of class. We still have to take it in class test.
Well, the last time class is supposed to be.
Huh. Hopefully, maybe the times will conflict and I won't be able to give you an in-class test. Okay, so we'll cross that bridge when we get there.
Yep.
Because I really don't want to give it. But anyway, this is how you find your other classes, your conventional classes. You go here, you find the times that you meet, you go by the campuses, and boom, you show up at that time in the room. Okay, we'll worry about ours when we get there. I'm going to have to figure out something. I'm going to have to get with somebody above my head to do this because they have to, we got to figure this out. I didn't think about that. It'd be easier to switch the Anderson campus to December 4th from 10 to 12 would be the easiest thing to do. But of course, you know what's going to happen when I do that. 6 people are going to say, oh, I can't make it. I got another, I don't know how we're going to fool it. But anyway, the reason for me to show you the exam schedule is not for this class. The reason for me to show you exam schedule is so you'll have it for your other classes. And so you won't be asking them DA questions. Okay? That's how you find that. Let's go back to the whiteboard. Your final exam online, the one that I really care about and the one that goes into your grade instantly, is going to be 2 attempts. And again, like I've been doing for the last 3 or 4 tests, take the higher of the 2. The reason I give you 2 attempts is for those that take the final exam during a lightning storm or your modem that you're using since 1985 is not working. Okay? Last week, what am I doing during the last week and during finals? That's when I do a lot of my office work. I start to tweak the grade book to make sure everything is working in the grade book. All right, I want everybody to listen to what I'm fixing to say. You may see your grade fluctuate a few points. Usually it's to the good. Why? Because let's say that I take out, what chapter have we not been in? We haven't been in chapter 11, have we? All right, let's say that we do 11.2 and 11.3 homework, but I take out 11.1 homework. Well, each of these assignments are weighted a certain number of points. So 11.1, if I take it out, I've got to do something with those points. So what do? I distribute it with 11.2 and 11.3. So therefore, if the computer sees that I don't have nothing for that 3 points, it may calculate it as a 0 or it may hurt your grade. So I take those 3 points for 11.1 that we omitted and I put that on 11.2 and 11.3. So you may see your grade fluctuate. You're talking 1/10 of a point, 100th of a point, maybe up to a point. You may see your grade fluctuate that last week. So that's all the more reason for you to run around in circles, panic, and call my office 15 times, right?
Absolutely.
Yeah.
Definitely.
That's what you're supposed to do. All right? If you see your grade fluctuate during that last week or during the finals, it's no big deal. It's usually going to be a better grade. If it fluctuates, it usually is going to go up. All right? What's the assigning zeros? Well, some of you may not have completed an assignment. If you didn't complete an assignment, I will go through and check all the assignments, and I'll hit a button that says assign zeros. It will go through, and any questions that you didn't do, any homework that you didn't do, period, it'll give you a 0. So if you didn't do one question on 5.1 homework, it's going to give you an incomplete for that question, which will drop your grade on that homework from 100 to a 98 or to 100 to a 99 or whatever the case may be. If you didn't do a whole section of homework, it's going to give you a 0 for that whole section. Okay, so you're going to get a 0, and that's when you will see your grade decrease. Now, I usually do that the first 2 or 3 days of finals, so you might see your grade fluctuate there a little bit. Well, Hubert, what do you do to homeworks that we skip? I omit them. That's what I'm doing by fine-tuning the grade book and moving the weights. That's what weight is for. I move the weights around to where if we omitted something, it doesn't hurt your what? It doesn't hurt your grade. So during the week of finals, that's what I'm doing. Now, what is homework and test question mark? Well, sometimes I have been known to do something the last week of class. I don't announce it, and I don't tell you what I do. But just remember this. If a teacher accidentally gives you a 20-point curve on a test, are you going to stand up and say, Miss Smith, you gave me an extra 20 points. You need to take it off my test?
No.
Hell no. Who's putting on
Okay. Now, if you see something that's to your advantage on MyLabs Plus, you do not email me and say, I'm confused. Does everybody understand that?
Yes.
Okay. Somebody will. Somebody will call me or email me or text me and say, I just saw something on MyLabs Plus and I don't understand it. And will you get a reply? No, you will not. All right. Any questions about final exam?
No.
Any questions about grades?
No.
Okay. Now, as far as the in-class final exam that we have to do that I really don't want to do, we will cross that bridge by the last day of class. I'll figure that out, okay? I need you, though, to make sure of your schedule so we can determine if we can meet here either on December 4th or December 6th. It would be easier for the Anderson guys to figure out their schedule because these three can meet on December 4th. So if y'all could meet, what was that time on December 4th? Did y'all see it?
I think it was 10:10 to 12:10 for both of them.
Okay, see if y'all, the Anderson campus, see if y'all have that open. And if you do, then we'll have it on December 4th. But we'll communicate that as we go along. Okay, that should take care of that. I'll be announcing some more of this as we get closer to the last week. But I'm starting to notice that some of y'all are starting to do trimmers, okay? We've got about 3 or 4 weeks left or whatever, and some of y'all are starting to do Twitch. Okay, that means y'all are getting toward the end of the semester, you're starting to have convulsions. I don't want to be part of those convulsions because convulsions and panic produce DA questions. And I don't want DA questions that I have on my test 4 or 5 times, and just because of the panic and the anxiety, you decide to ask one of them. Capiche? I know, I'm a bastard. Okay. I was in the Boy Scouts. All right, so we did sine. Now let's look at cosine.
Is this 10.2?
Yes, sir.
Law of cosine.
Law of cosines. We went over the law of sines last time.
Right.
Now, when you're using the law of cosines, you're basically worried about a side angle side or a side side side. This is where you have the only two that you really don't have on the law of sines. Okay? And they're giving you an example right there. And it says if you have a side, and a side, and the sides don't reach each other, it's pretty much impossible to have the triangle. In any triangle, the sum of the lengths of any two sides must be greater than the length of the what? Remaining side. And that pretty much is self-explanatory. And most of these are going to be used with an obtuse triangle. Most of your acute triangles are going to be with the law of sines. A lot of your obtuse triangles are going to be with the law of cosine. So let ABC be an oblique triangle drawn with the vertices labeled in the figure below. And we start to see that if you drop a perpendicular line right here, go basically through the derivation that we went through with the sine. I'm not going to spend time on this, but basically the next slide will show you the law of sines or law of cosines, and that is right here. Now there's 2 or 3 different variations. Hopefully on the next, there we go. Write those down and make sure you know them. Now all you got to do is interchange. It's not a big deal. The minus is always, and you see the pattern. Okay, let's look at the pattern. BC, BC, AC, AC, AB, AB. There's the pattern. So you don't really have to memorize. All you have to memorize is the first one, and then just substitute in whatever's left and whatever you need. Now again, I told you before that this section pretty much, besides the first unit, the right angle trig, this unit is probably the second easiest, or the first easiest, whichever you think is easier. The right angle trig, or you've already done the hard part, which is the identities. Now this is just plug and chug and solve. You might have to use a little bit of critical thinking, you know, the puzzle type triangle, but it's not a big deal. Here's an example. Solve triangle A, B, and C if A is 42.3 degrees, B is 12.19, and C is equal to 14.4. So if we've got A, so we know we're going to use A, so that means B and C are going to be in, so it sounds like to me we're going to be using the law of cosines. Let's go back to the law of cosines. Which one has the cosine of an angle A? So you're going to know, you automatically know you're finding side A because of this relationship right here. Now we said we had a relationship, and the reason I have to go through this is because I realize that some of y'all invented these identities, but some of you didn't. B, 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 C. A corresponds with what you're looking for. So if you make those relations, you won't have to memorize all 3. You just memorize, you know, the relationship. So we're going to be finding side A. So let's take our handy dandy do-jigger and let's do it. I'm just going to write out to the side because they're going to do it. So we know that what? A squared is equal to, and what is it?
B squared plus C squared.
B squared plus C squared.
Minus 2 AC cosine angle A.
Cosine what?
Cosine, this would be 42.3 degrees.
No, I don't want that. I want the cosine of A.
Yeah.
Okay? That's supposed to be BC right here, isn't it?
Yeah.
Okay? Now, that relationship, I just called it because of the relationship. So, A squared, if I wanted to go ahead and take the square root of that, then I could do that, and we get A is equal to the square root of 12.9 quantity squared plus 15.4 quantity squared minus 2 times 12.9 times 15.4 times the cosine of 42.3 degrees. Okay, start cranking that out. And again, another reason, especially for calculator drill team members, this test is pretty much 90% what? Calculator. No laptops, please. Remember, I prohibited laptops. Not picking on anybody, but none of my classes have laptops anymore. You can blame whoever it was that watched the movie while I was teaching. Maybe explains why that person has an F in my class. Oh, it's not in this class either. So, but I have to do it in all classes since one person screwed it up for everybody. Now, I'm not going to do all that because I'm not a calculator drill team member and it'd take me a long time to do it on this board calculator thing. So we'll just look at what they did. And there it is. 109.7, and then take the square root of that, and you should get the answer. So the law of sines and the law of cosines is nothing but what? Plug and what? Plug and chug. So let's do a nerd. Okay, well, you can go through and do, okay, I forgot. You got to find, they want something else. So let's go back. I'm sorry, I forgot. We found side A. Okay, now that you found side A, you can use the law of cosines to find C or B. So go ahead and do that. So A is equal to 10.47. So we'll take our 10.47. So I'm going to erase all this now. Now y'all take the law of sines, which is real easy. I don't have to memorize those. Just got to say A, B, and C. But what we got? We got A. And we got A here. So that's 10.47 over sine of 42.3 is equal to, well, pick one. What do you want to get, B or C? B. So B is what? 12.9 over sine of B. Okay, find angle B. Go ahead and do that. And then use your 180 degree rule to find angle C. What class is this for?
So now you're back to using the law of sines after that?
I'm sorry, what?
You're back to using the law of sines after?
That's what we're doing right there, yeah.
Okay.
Vietnam War.
I gotta rewrite it though.
That was one war that we should have won, but we had our hand tied behind our back. Thanks to those people in Washington, D.C. And one vice president who wanted the other president killed because he wanted money off the war. Oh, I'm sorry. Should have said that. So that's going to be inverse sine of 12.9 times the sine of 42.3 divided by 10.47. Is that right? Let's see what it comes out to be. Crisscross. So that's going to be 12.9 times sine of 42.3 divided by 10.47, then divide by the sine, which will give you the inverse sine. Somebody crank that out. Oh, that's, I like that. Somebody crank that out and give me an angle, please.
56.
I can't hear you. What?
56.02.
Oh no.
You didn't get that?
No. I'm talking about.
Okay, let's go back. Here we got 56.02.
I might be right.
Pendleton, what do you have? Okay, let me go to Easley. Go to Oconee. Easley and Oconee, what do you have as far as an angle for B?
That's what I got, 56.02.
Got two that says 56 point what?
02.
O2. Who else?
I got that.
We already got Anderson campus. We don't need, you need to be quiet. Let's ask Miss Crittenden. She talks to me.
I don't
Miss
have
Crittenden,
my
what'd you get?
I don't know where my calculator is.
God, I tell you what. You know,
I'm
see
sorry.
what happens when you're on drugs? You forget things and you forget where you put stuff. And Miss Crittenden, you're just a disappointment. I don't know what I'm gonna do with you.
Sorry.
You need to quit partying so hard. All right. How about Pendleton? They're not gonna say anything. So anyway, all right. So we'll go with 56 point what?
02.
56.02 degrees. Okay, now by the 183 degree rule or 180 degree rule, 42 and 56 is 98.32. So that's going to be what? 82 point, I don't know what it's going to be. What is it? What's this one up here?
$81.68.
81.68. Everybody confirm that? Everybody confirm that? I got one. Anybody?
81.68.
Yes.
Okay, good. Thank you for the communication. Thank you, Ms. Rudiker.
Anytime.
It's the communication, it works, doesn't it? Now she's not. Next. 81.7, what did we get? We got 81.68, so we know what we're doing.
What?
All right, try that one. Solve triangle A, B, and C if A is 9.47 feet, B is 15.9 feet, and C is equal to 21.21 feet, or 21.1 feet. Well, what's 9 and 15? 24 or 26, somewhere around there. So, yeah, it's possible. But if it had been 15 and 3, wouldn't be possible. Why? Because C is going to be usually your longest side, and you got to have, at least 2 long sides to. You can't have 2 short sides to get the long side to meet. It doesn't work that way. Think of a 12-foot gate, and you got 2 5-foot gates to put across it. A 12-foot driveway, and you got 2 5-foot gates. Is that going to go across the driveway?
No.
Okay, that's the same thing as with the triangle not working.
Makes
Talking to a rock.
It makes perfect sense.
Yeah, well, thank you. All right, so let's see. Let's get their drawing up here. Okay, they didn't even draw it, so let's draw it. Now, I guess they don't want to draw it.
Yeah. Okay.
So I always just put A on the left-hand side since I read from left to right. I just start right there and I put a dot. And we know that 15.9 feet or 9.47 feet, is that the shortest side?
Yes.
Yes. So we just draw a short side there, and since we read from left to right, that's going to be B. All right, we know that angle B is 16 feet. Just draw that, and we know that this one is going to be the longer side, so it looks something like that. I have no idea what it looks like. I'm just going with what I'm given. Okay, so this is 21.1. This is 9.47. I'm sorry, 9.47, and this is 15.9.
It's supposed to be across from the letters. I got a question.
Mm-hmm.
Aren't the numbers supposed to be across from the letters that are corresponding?
Yes.
Okay, I'm sorry. Yep, you're right. So we'll just call this one A, and we'll call this one, what, 15.9B. You were right. I'm sorry. I was thinking too much of drawing it out, and this is C. We'll go with that then. Making sure A and B and Let's see. My bad. I had the sides right. I just had the angles wrong. I'm sorry. Now, we know that I'm just going to go here and I'm just going to write this down because a squared is equal to what?
B squared plus C squared.
B squared plus what?
C
Plus C squared. That's the Pythagorean theorem. But what about the law of cosines? A squared is equal to what?
B squared plus C squared.
B squared plus C squared minus what?
2BC.
2BC
Cosine A.
cosine of A. All right. Now just look at this, and we know that these two sides right here and these two sides right here, we know we're trying to find what? We know we're trying to find angle A, so it's very possible, since we have all three sides, that we can just plug and chug.
Right.
So, A is going to be 9.47 is equal to 15.9 quantity squared plus 21.1 quantity squared minus 2 times 15.9 times 21.1 times cosine of A. All right, start condensing all that down because basically all you have is a math problem with an X, or you got an algebra problem with an X. And this is your X. You're going to have to take the inverse sine of whatever you get on the left-hand side. So you need to manipulate this and get everything on the left-hand side. So 9.47 quantity squared, and then we're going to subtract 15.9 quantity squared plus 21.2 quantity squared, right? Over what? Negative, or yeah, divide, right? Divide by -2. Y'all help me out. 15.9 times 21.1, and then take inverse cosine of that. Y'all check my math and make sure I did the algebra right. It'd be easier if you turned everything into numbers,
Wait.
but
For 15, since you're putting it all on one side, wouldn't it be minus 21, the square root of 20?
I thought I put minus. I'm sorry.
No,
Yeah. Okay.
because of the
Okay, everybody say, yeah, I thought that was right. Everybody say that. 1, 2, 3. Say it.
Yeah, I thought that was right.
There you go.
Yeah.
Right.
My PhD.
Yeah. I think that's, yeah, because you got to come out with a negative to make it positive. So somebody check, make sure, because it'd be easier if you turned all of these into numbers and then worked with it, because these two would combine, and then you subtract this, so then that would be that, and then you divide by this. That would leave. I think I did it right. Somebody tell me what angle you get. And that's going to be angle A, which is up here. Sorry. And let's just, well, no, you better take it at least to the 10th of an angle. At 10th of a degree. What'd y'all get?
I haven't entered it in yet. This was deep.
Pendleton, now, if y'all get the answer, you shout it right out now. You hear me?
49.
I'm sorry, what? Okay, 24.95. Do I have a second?
24.95.
Okay, we got 2 people. One more and we'll take off.
24.9.
Okay, we got 3, so that's good. All right, now, we've got this angle at 25 degrees. Now what we're going to use? Law of what?
Law of sine.
Law of sines. You're going to start to find that whenever you use the law of cosines, usually the next step is to use the law of sines. Most of your problems, okay? So, use the law of sines, and let's find angle B. Let's all do the same thing. Let's find angle B. So that's going to be 9.47. Let me do this in another color, because I try to do things good for y'all. 9.47 over sine of 25 degrees is equal to B, which is 15.9. 15.9 over the sine of B. So that's going to be 15.9 times the sine of 25 divided by 9.47, and that's going to be the inverse sine of that number, and that's going to be equal to B. So somebody do the math and tell me what you get when you take the inverse sine of 15.9 times the sine of 25 times 9.45 divided by 9.45. Again, calculator drill team. This is a calculator question with only about 10% algebra in it.
45.2.
45.2 to have a confirmation. 45 degrees is good enough for government work. Right now, showing you how to do it, because they're going to decimalize everything when I hit enter in a minute. So I got 45 degrees and 25 degrees. That's 70 degrees. So what's this one? 100 what? Or 130 or what I say? 110? What is it?
Yeah, 110.
110-ish. Okay, remember, do not think that your drawing is to be scaled. Okay? Please don't think that, because if you look at a problem and you say, oh, that don't look right, and you change the problem, that's why they didn't draw it. Okay? Now, the reason I drew it is because I have to think, and sometimes it messes me up, but I still think. Yes, sir?
What? We got 45 degrees for B, but we wrote down 110.
Did I write down the wrong one? I'm sorry. Oh, there's the 110 right here. I'm sorry.
Thank you.
I suck. I think I just need to go home. What do y'all think?
Yeah.
Sure, plan.
Oh, I thought for sure penalty would jump up and down. Let's see. What did we get for B? 45?
Yeah.
There we go. Sorry, I switched that around.
Wanted to make sure.
No, you just want to point out my mistakes. That's what you want to do.
Absolutely.
Yep. That's all right. I'm going to get me a gallon jug of water and carry it around. All right, there's the 109 degrees. So they went for C and got 110 degrees. Did y'all get 110?
I saw him.
Yes.
And 25?
Mm-hmm.
So we did that right. We feel good about ourselves.
Yep.
And of course, you can see they're giving you the kind of keys to doing it. But basically, it's a puzzle. Once you do 2 or 3 of these problems and 2 or 3 of the sign problems, you're ready for 30%, 33% to 40% of your test on this unit. Okay, so you're ready to go. When you get 10.1 and 10.2 done, you're ready to go. Now, go ahead and write down Herons Formula. I don't test you on this, but it's something that you need to say, oh yeah, I saw that in trig. Everybody understand that?
Yes.
Okay. If a triangle has sides lengths A, B, and C, and if the semi-perimeter is, in other words, semi-perimeter, you can look that up, that's semi-perimeter, it's half the perimeter, is 1/2 A plus B plus C, then the area of the triangle is square root of S times S minus A, S minus B, S minus C. Now where that comes from basically is a distributive property, but we won't go there. We're not going to derive it, but that's where it comes from. But anyway, that is the area of the square root of the product of 4 factors, the semi-perimeter, and the 3 differences of the semi-perimeter and the individual side lengths. Now, the best thing to do with Herons Formula is to write down the two formulas and do an example. This is one of those times when it's the best thing to write it down, tab it in your notebook, and say, okay, I went over this, and then just remember to plug and chug, because basically that's what you're going to be doing.
Wait, go back.
Yes.
My gosh, people, it's just two formulas.
I'm slow writer.
I was writing the definition.
Really?
I'm just a very slow writer.
Oh, well, let's go ahead and do the derivation. No, I'm just kidding. Okay, is everybody through writing down did everybody get the period on the bottom down there? Everybody get the period?
Oh, no.
How about the apostrophe? Did everybody get that?
I get the comma.
All right. The distance, as the crow flies, which I might have to explain that to some of y'all because of your parents, from Los Angeles to New York is 2,451 miles. From New York to Montreal is 331 miles. And from Montreal to Los Angeles is 2427. What is the area of the triangle region having these three cities as vertices? Ignore the curvature of the earth. You reckon? Since you're flying through the mountains and the plains, you're going to ignore it? Yeah, of course you are. All right, but anyway, draw a picture of it, just so you have some idea of what you're dealing with. Okay, I don't know if they're going to draw a picture of it on this next slide or not, but we'll see. But hopefully they will. Oh my gosh, look at there, they did.
They did? Oh. I'm so...
And there is your S. 1/2 2451 plus 331 plus 2427 is equal to 2,604.5 square feet. I'm sorry. That's the perimeter. I'm sorry, perimeter. And then the area, you plug in the area and you get 401,000. Now, of course, you need to divide that by 43,560. So take 401,700 and divide that by 43,560. Somebody do that. 43,560. How many acres is that? 9.22. Oh, that's square miles. I'm sorry. That's square miles. I was thinking square feet. I'm sorry. Square miles. So that's just a big ass piece of property. Okay? All right? Because you're talking miles. You got to multiply that by 5,280. Then you have to divide by 43,560, and that'll give you the acres. All right? So we're not going to go there. You have to do, that'd be a lot. Well, you could do that. That'd be a lot, though. You'd have to multiply. That'd be a big piece of property. So, okay. Do you understand why I'm not spending a lot of time on this? To me, plugging and chugging does not necessarily mean you know how to do algebra or trig. Okay? It means you know how to do algebra, but not trig. This is a trigonometric problem, but all you have to do is plug and what? Chug. It's not really detrimental to your passing calculus. Okay? Now, the identities, the right angle trig, the law of sines, law of cosine, that is detrimental. This is not. This is a good standardized test question that would be on an ACT, a GRE, or something to get you into whatever. Okay? So make sure you know how to plug and chug. Is it a test question on my test? No. And this is area, I'm not going to insult your intelligence by this. The area of any triangle is given by A is equal to 1/2 base times the height, where B, okay. I'm not going to do that. But what they're going to get to is basically this. When you have side, angle, side, you can actually use the law of cosines and the law of sines, the law of cosines to actually, if I was to, let me just show you a trick I learned in the war. If you was to actually take this formula right here, really, hold on a second. There. If you was to actually take this right here, and you was to incorporate the law of sines into this, I mean the law of cosines into this, right here, then you would come up with the next. It would be so nice for this thing to work. There, you would come up with that. So again, you need to look at the relationship A sine of A, A sine of B. You need to look at the relationship here, here, and here. It looks like AB, AC, and BC. So you got to see the relationship. BCA, ABC, ACB. Again, this is not detrimental for calculus, but it is something that you need to highlight as for your information. So find the area. So which one do you have? You have angle what? Go back. You have what? You have angle B. Don't you have angle B?
Yes.
Okay, you have angle B. Which one is angle B? It looks like AC sine of B, right? That's the one you're going to use. So AC, let's go back and see if AC's in. Limit. AC. Let's see. A and C. Golly, that fits.
Wow.
So plug that in, and you get the square feet. Now, take that and divide by 43,560. And that'll give you what? 1/8 of an acre or a half acre or whatever. 43,560. What's 585 divided by 43,560? You got your dang old 1/100th of an acre of land right there.
Oh, yeah.
Dang old postage stamp. We used to survey lots. Me and my father used to survey lots. And I found out one of the reasons I hate dogs. Now, I don't hate dogs if you have a dog. If you have a dog, that's good. Knock yourself out. I love that dog. I just hate dogs if they're given to me, okay? Anyway, the smaller the piece of property, the more dogs you have barking on that piece of property. And the more fences you have on that piece of property. You survey a half acre of land, it'll have a fence around it, 15 dogs in that fence. You survey 40 acres, there'll be no fence and no dogs. I don't know. Y'all figure it out. That's one of the reasons I don't like dogs. All right. So, if you have 585 square feet of land, if you have a piece of land that's 34 by 42, then and got a 55-degree angle, then you got 1/100th of an acre of property. And that's it on law of sines and law of cosines. Now you want me to give y'all a test on the law of sines and law of cosines just by itself?
Yeah.
Right now, let's just do
Somebody would fail it. Anybody want to bet me? All right, let's work on vectors. Now this is on a scale from 1 to 10, with 10 being important, this is about a 15. Okay, because you're not only going into vectors with physics, you're going into vectors in Calc 2 and Calc 3. Calc 3 is nothing but vectors. And plugging and chugging. So, if you ever sucked at physics, if you ever sucked at vectors, you might want to pay attention. Now, I do realize that one or two of y'all invented vectors. Okay? You invented physics also. But for those of us that did not invent physics and did not invent the vectors, we would like to learn them, okay? And the first thing that you have to do with learning a vector is the terminology. Now, I have told y'all this probably before, but why do people fail accounting?
It's too much math.
Nope. The math is actually first and second grade math.
Too many numbers.
Vocabulary.
Who said that? Wow, how did you know that?
Well, you told us before.
Oh, you did? I did? I didn't think y'all would. Y'all actually listened? Wow. I figured everybody was like Pendleton campus and just didn't care. All right? Or don't talk, one of the two. Anyway, I can't even talk bad about them. They won't even respond. I can say whatever I want to. They just sit there.
It's like a brick wall.
Yeah. Oh, well. It's still sitting there. Anyway, y'all do this in y'all's other classes, Pendleton?
Yes.
So it must be very interesting in those classes too, right?
No.
Okay. Y'all ever think that if y'all would talk in your classes, that the classes might be a little bit more interesting?
No.
How do we do that?
No. Okay, well, that's good. You'll have a closet, wherever you work, you'll have a closet that you can be in. That'll be good. All right, so basic terminology. A scalar is a magnitude. Now, basically, there's two things about a vector you should know. A vector is made up of two things. Can anybody name them right off? A direction and a magnitude. Write that down. Now, they can call it many different things, but that's what a vector is made up of. A direction and a magnitude. A direction is given by the angle. Okay? Direction, it could be a bearing, northwest, or it could be an angle. And then a magnitude could be 10 pounds, could be 5 miles. Magnitude is a 25-cent word for a unit of what? Measure.
Right.
Write that down. They call it a vector quantity. Okay? Magnitude with direction. So this is a vector. Now, also make sure you understand that a vector is written AB, and then it's got a line like a vector right on top of it. Now again, I'm not teaching the people that invented physics. I'm teaching the people that never has seen or haven't seen vectors in a couple of 3 semesters. Okay? Vector OP and PO. The first letter, we read from left to right. Miss Crittenden, you got a question, or are you just making...
Oh, no, I'm sorry.
Oh, I thought you were looking like... Okay. All right. The convulsions, that's fine.
Yes.
Anyway, OP, you read from left to right. If you wanted PO, then that means you're reading from right to left. And that's very important. Opposite directions, that's the sign. Remember me telling you a long time ago, the only thing a negative and a positive tells you in math and science is nothing but 100% starts with a D. What? I.
Direction?
Direction. Negative and positive only tells you one thing, direction. A lot of people say, what about negative $500 in the bank account? What does that mean? Below what? 0. Below is a direction. All right? Everything having to do with the positive and negative in real life, science, math, is direction. So if I tell you negative OP, then negative OP would be in this direction going that way. Okay? Let me just forget it. I'm not even going to try it. Let me just make sure that's the next slide. Okay. So negative OP, let me turn this thing on, and this is vector OP right here. And if I gave you negative OP, it would be same magnitude. It would just be, okay, this thing's going through convulsions now. Miss Crittenden passed a convulsion to my screens, and now they're going haywire. Okay, negative OP would be this way right here. Okay? Okay, y'all have to bear with us here at Anderson. These they're flickering. I don't know if you can see it or not, but my screen and this thing's flickering, so.
You broke it. Good job.
Yeah. It's always the man's fault.
Training on these devices.
Yeah, one day we'll have training. And we'll be able to turn them on and use them.
In 2 decades?
Yeah. By 2024, Tri-County Tech will be up with technology.
Innovative teaching methods.
Okay, next one. Now I can't turn it on.
Posters everywhere.
There we go. Yeah, or posters. Two vectors are equal only if they both have the same magnitude and direction. So they cannot be equal if they're going in different directions. They cannot be equal if they have two different angles. Okay? Now, there's two types of, there is the bisection, and then there is the head to tail method of adding, getting the resultant vector. I'm used to calling it the resultant vector. Okay? One is to draw a diagonal. The other is to go from head to tail, and that's what this one's doing. So if you take angle B and you pick it up and you move it over here, that's head to tail. So this is head to tail right here. I'm sorry. I thought I was working. Okay. The one on the left is head to tail. The one on the right is bisecting a parallelogram. Do they give you the same red vector? Yes. So it doesn't matter which one. And this is where a lot of students go into physics and they get confused because the teacher is using head to tail and the big teacher told them to do the parallelogram, and they go into physics and their head explodes. It's the same thing. Okay, because you're basically going to be using the law of sines, the law of cosines, or the Pythagorean theorem, especially with the normal vector with the Pythagorean theorem, because the normal vector is always perpendicular to the velocity vector. Okay? I'm sorry. I'm not supposed to say stuff like that because I'm supposed to be just a dumb redneck. All right, next. Here's where we get into scalar vectors. You talk about scalar product, that means you multiply the unit vector by 3. If I have a unit vector of 1i or 1j, whichever one, if you're in electronics or you're in trig, or 1i is the same thing as 1j in electronics. If you multiply 3 by the I vector or the unit vector, then you get 3i, or you get 3 times the unit vector. A scalar is just nothing but a multiplier. Okay? So make sure you understand that. Because a lot of people, this is what happens. You go into physics, and the physics teacher is throwing scalar around and unit vector around, and you don't know the difference between two, so you add confusion on top of what? More confusion. So make sure you know the terminology. A scalar product is a unit that you multiply by the unit vector. So the unit vector is usually by u. There's the unit vector. If I do 2u, the multiplier or the scalar is 2, the unit vector is u. So that would be 2u. The 2 u's. The 2 what? The 2 u's. What's a u? My Cousin Vinny, good movie. Y'all probably never seen it. A vector with its initial point at the origin is called a position vector. Okay, this is where you get into Calc 3. And you have a position vector versus a normal vector. You've got the x, y, and z axis. You've got a particle in space. You've got a position vector going from the origin. We'll use a blue vector. Going from the origin to that vector. Okay? That's called a position vector. It's coming from the origin of a 3D or a two-dimensional graph, and it's called a position vector because it comes from the what? Comes from the origin. And at that particle in space, that's where you come with the normal vector. The normal vector is going to come from the position vector, and it's going to be, wrong color, it's going to be green, and it's going to be, could be going, if it's going this direction, that normal vector is going to be 90 degrees off of the what vector? The position vector. And that's going to be called the normal vector. And then from the normal vector, you can get your tangent vector. And that's all in Calc 2 and 3, the latter part of Calc 2 and the latter part of Calc 3. Physics, you're just going to be doing a lot of work and stuff. But anyway. And horizontal component. This is your horizontal component. We're dealing with the XY axis. So I'm kind of crunching a lot of this in because I know some of y'all invented physics and y'all are getting bored. But here, let's say this is your X axis, and I'm trying to do this while my monitors are blinking, so it's kind of distracting. here is your x coordinate, and this is your what?
Y.
Your y coordinate. So that point right there has a what? A x and a y. And of course, when you're talking about z, you're talking about something totally different. You have an x, y, and a z. But you got to crawl before you can what? Walk. It's your parents' fault. Did y'all ever figure it out? Some of y'all are still wondering where the crow flies. Anyway. Oh, look at there. There's our old friend Pythagoras. The magnitude. Now, this is very important because you're going to see this, and you're going to see a lot of it in physics and calculus, and you're going to forget what it means. Okay, what does this mean? That means the magnitude. When you see the absolute value, why does it have absolute value on magnitude? How many of you ever seen a highway sign with a negative number on
Nobody?
I'm
it?
assuming.
Nobody. Have you ever seen a highway sign with Atlanta, 200 miles? Then you come in from Atlanta and go back to Anderson, it's negative 200 miles? Distance can never be what? Negative, so that's why it has an absolute value. So now you don't have to remember absolute value, you just have to think magnitude is another word for distance, okay? And distance is never negative. So therefore, when you see these absolute value marks, you automatically know that it's going to be distance. And of course, the distance of a triangle is equal to what? A squared plus what?
B squared.
Plus b squared. Now, you will use other variations of the Pythagorean theorem, but all of this should be like, oh yeah, I remember that. That's why this one is so important. Now, the first thing you do, let me check the time because some of y'all act like y'all are going into convulsions. I got about 5 minutes. We're going to do this problem, and then the rest of y'all can be rude, okay? After I finish this problem, then I'm going to open it up to rudeness. All right, 3 and 2. We got a vector that's at 3 and 2. So that means the x is what? 3. And the y is what?
2.
Negative 2. I was going to draw it, but there it is.
You saved yourself
Yeah, exactly. So that makes list one more minute of rudeness. So that means 3 squared plus 2 squared. 3 squared is what? 9 plus 2 is what? 9 plus 4 is what?
13.
13. So the square root of 13 is your vector, your resultant vector, or your measure of your vector. Okay, we're going to go ahead and stop. And these monitors are driving me bananas. They're putting us to sleep, hypnotizing us over.